the sun was only 80% as luminous as it currently is. Such conditions today would result in freezing of Earth's oceans, but geological evidence shows that water rather than ice filled the oceans at the time. Heat is trapped within Earth's atmosphere through the presence of carbon dioxide, which, like methane, is a greenhouse gas. Only if the level of greenhouse gases were higher 3 billion years ago than it is today would Earth have retained enough heat to keep the oceans from freezing. It is likely, therefore, that the level of carbon dioxide in the atmosphere was significantly higher then than it is today. So it is likely, therefore, the level of carbon dioxide
was significantly higher than it was significantly higher then than it is today. And what is our reasoning for it? Can you explain this to me?
Okay, so the level of carbon in the atmosphere is higher back then than today because back then the sun wasn't as bright as it is today, and because of that, it would have made it should have made water freezing, but it wasn't. It didn't make it freezing. It was still water because there was heat in the Earth's atmosphere due to carbon dioxide, which is similar to methane, both being a greenhouse gas, but only if that level of the greenhouse gases was higher 3 billion years ago than today.
Yes, and what does only if introduce?
As sufficient? No, necessary.
Nope, if is sufficient, only if is necessary, because only has N in it, so it's necessary.
Oh, okay, that's a good one.
Okay, so if Earth retained enough heat to keep the oceans from freezing, so if the oceans did not freeze, what does that mean happened?
There was 3 times the level of greenhouse gases back then.
Yeah, the greenhouse gases were higher. So if the greenhouse gases were not higher 3 billion years ago,
then they were frozen.
The waters would have froze. So then we're saying, therefore, the level of carbon dioxide in the atmosphere was significantly higher then than it is today. And we're saying it was higher then because what happened?
The oceans were liquid.
Yes.
They were water.
Yes, they were water. Excellent. And so what is the flaw here? Like, why can't we guarantee this?
It could have been something else that kept it liquidy.
What is our conclusion?
That the level of carbon dioxide was significantly higher than today.
Higher. So have the oceans ever froze?
I don't know. Maybe.
Not that I know of, right?
Yeah.
Okay. So just because the gases were at a level that they didn't freeze, does that mean that they're significantly higher than it is today? Because is it freezing today?
No. Oh, so it doesn't mean it was 3 times higher. It could have been, we don't know, but that's not necessarily the reason why.
Excellent.
It's not frozen.
So yeah, so I would predict something like okay, so we're saying that the sun was only 30% as luminous as it is currently. And so since it was less luminous, things were like more likely to freeze.
Mm-hmm. But
since it didn't, it must be significantly higher. Well, couldn't they both go up, I guess, is what I'm thinking.
They could go up, but we don't know.
Because the temperature was high, even though the sun was not as strong as it used to be, right? But couldn't there be something else that was making it high other than carbon dioxide?
Yeah, it could have been a different gas.
Yeah, of course. All right, so go ahead and walk me through these answer choices.
Okay, which of the following if true weakens? Okay. A. Sufficient heat to keep the oceans liquid 3 billion years ago could not have been generated through geological processes such as volcanic activity. Okay, so sufficient heat to keep the oceans liquid would have not, okay, but just because they're not generated through volcanic activity, it could have been from a different way.
Right, this almost strengthens our argument because technically we're weakening this. So we're trying to say that the level of carbon dioxide in the atmosphere was not significantly higher. And so we're like this almost, so it was not significantly higher. So what this does is it almost like it rolls out another reason that the heat might be. So since it could not have been from volcanic activity, it almost strengthens the idea that it came from carbon dioxide, right?
Oh, so okay, it's not like it's eliminating the possibility of
Yeah,
it
it's
being
it's
volcanic.
strengthening it by eliminating a alternative possibility.
Okay, I get it. Okay. The geological studies indicate that there is much less methane in Earth's atmosphere today than there was 3 billion years ago. There's less methane today than it was back then. But, oh, carbon dioxide is like methane.
Excellent. So if there's much less methane today, why does this weaken this argument?
The level of carbon in the atmosphere is higher. Wait. Because carbon dioxide is like methane. Wait, I don't see how that weakens. I thought I did when I was reading it. Hold on. Let me indicate that there's there's less methane today in the atmosphere.
Okay, so what we're saying here is that the level of carbon dioxide in the atmosphere was not significantly higher than it is today, because we're trying to weaken the idea that the level of carbon dioxide in the atmosphere was significantly higher then than it is today. So if we would say that actually the reason that it was so hot back then was because there is less, like there was more methane back in the day, maybe it wasn't the level of carbon dioxide that was significantly higher than today, it was the methane.
What? But how do we know it was methane? How do we know that it decreased? Like, what if it's been the same?
But it's a weakened question, so we could bring in new information. So it says geological studies indicate that there is much less methane in Earth's atmosphere today than there was 3 billion years ago. So what does that mean happened 3 billion years ago? There was more methane, right? 3 billion years ago.
Yeah.
So how do we know that it was that there was more methane 3 billion years ago, or was there more carbon dioxide 3 billion years ago?
We just know there's more methane, but methane is similar to carbon dioxide.
Yes. So if there was, so this gives us this points out an alternative possibility. And it's like, well, how do we know it's the carbon dioxide then? It could have just been the methane.
Oh, okay. So
that's why the answer is B.
Oh, but okay, because I thought I was just strengthening it because it was kind of